This project uses machine learning to predict customer churn for online shops. It identifies customers at high risk of stopping purchases so that managers can take proactive retention actions, like sending discounts or targeted campaigns, before they leave. The system combines a FastAPI-based churn prediction model, a Streamlit dashboard for user interaction, and a Flask backend simulation, demonstrating a full end-to-end ML deployment workflow. First, we train the model using a dataset of 500 customers with 11 behavioral and transaction features. These features include tenure, total spend, purchase frequency, recency, return rate, complaints, loyalty status, and engagement metrics like page views and cart abandonment. Short tenure and infrequent purchases increase churn risk. Low total spend and high return rates can indicate dissatisfaction. Complaints or low on-site activity often precede churn. Loyalty program membership reduces churn odds thanks to switching costs. We train a random forest classifier with class balancing to account for the imbalanced churn target. All project files are publicly available on GitHub. The README includes links to the deployed API on Hugging Face and the Streamlit app. These links are also provided in the description of this video. To test the API, we simply open the link and enter example customer data. API returns a binary churn prediction. 1 means high risk and 0 means low risk. The Streamlit app connects to this API. The app supports both single customer prediction through a web form and batch scoring by uploading a CSV with multiple customers. Let's test a customer with low tenure, low total spending, low purchase frequency, and low average order value. They haven't purchased in a long time since their last order. This customer has a high return rate, high number of complaints, and is not a loyalty program member. They show low engagement with few recent page views and a high cart abandonment rate. The model predicts this customer is at high risk of churn. Now let's try the batch scoring section of the app. Here, I have a file with 20 customers. After uploading, we click on Score. The app shows a preview of the input data, then calls the API for each row, aids a downloadable CSV with predictions. This makes it easy for business users to assess churn risk across many customers at once.
But what if we want to automate churn prediction weekly or monthly and send a list of high-risk customers to the marketing team? We need a pipeline that includes a batch prediction script and a GitHub Actions workflow. In our GitHub repo, the batch prediction script loads the latest customer data, calls the API for each customer, generates a dated CSV in the reports folder. If I open this folder, you can see the latest reports generated weekly. The GitHub Actions job is scheduled with a cron expression and runs entirely in the cloud. Each run locates the newest CSV in the reports folder, extracts the list of high-risk customers, and sends it as an email attachment to the marketing team automatically. This is the recipient email and the email's content. And here is the email that the marketing team receives every week with the list of high-risk customers attached. Let's see how to integrate churn predictions directly into an eShop backend using a mock Flask server. When a customer logs in, the backend collects their features, calls the Churn API, and, if they're high risk, sends an automatic retention email with a discount offer. To simulate this behavior, we use a local stub backend, a mock server that mimics how the platform would interact with the model in production. Let's see how it works locally. I start the Flask app and trigger an event such as login. The output shows the action taken, which is either high risk email sent or low risk no action. You can run the simulation multiple times to see predictions for different customer profiles. And this is the email that the high-risk customer will receive automatically. This architecture shows how churn predictions can be seamlessly embedded into live e-commerce systems, enabling proactive customer retention without manual effort. This model is just one example of how data can drive better business outcomes. I'd be happy to discuss how it can be adapted to your platform.